invite once again, sir, for the next session, which is on the topic tissue engineering with bioplotters. So again, we are here with Dr. Abhay Kumar sir, Abhay Kumar Kuthe sir. So I'll just introduce once again. He is a professor, higher administrative grade, with a former HOD in mechanical engineering in Vishwesvaraya National Institute of Technology, VNIT, Nagpur. So I hope we already had introduced him. So I hope I'll tell sir to now take over. So please, sir, now it's on your side.
So welcome back to all the participants. I think post lunch is a very disturbing session because at least pre-lunch you don't feel sleepy, but in post-lunch many of you may feel sleepy. So again a lot of responsibilities on my head, rather the on my shoulder to see that you should not sleep during this particular presentation. Hope you have enjoyed the working lunch, not the very heavy lunch, because I have taken the working lunch only. It's because I should not sleep, otherwise the whole motto will be defeated. Anyhow, so let's start with this very interesting topic about the tissue engineering with the bioplotter. I'm really happy to see that the whole session is given to me as far as the tissue engineering is concerned. Generally, I used to talk in many institute about the medical application, and there I just introduced about the tissue engineering. But now, with this whole session with me, I hope I can interact with you in detail, and at the same time, I'll be more happy to know from you more and more your questions, queries, comments, because ultimately, I think interactive teaching and learning is more important rather than the passive teaching and learning. So it's better that we should interact more once my presentation is over. And again, as usual, I always used to tell you that so there has to be some takeaway message from the presentation. So that aspect also we will discuss. This tissue engineering, I should say that it is a perfect amalgamation of medical science and engineering. And, the doctors, they feel closely associated with the engineering discipline in this particular field. But at this moment, the tissue engineering is more on a research platform, not on a deployment platform to that extent. Though we have tried something at our level to see that it gets deployed. But still, I think a lot of research is required to be done in the tissue engineering. But one nice fact about the tissue engineering that it has got a tremendous application. Once it gets deployed, it has got a tremendous application, especially when the organ development and other things are concerned. So I'm going to discuss about it later on also. But what is interesting here is that, as I already told you, that the doctors and engineers are working together closely in the tissue. So, as I mentioned to you, that this is related to the research. I'm going to talk about that quickly. These are the points to be discussed during my presentation. Introduction, what is tissue engineering, patient-specific scaffold now. Look, there I told you about patient-specific implant, and that is a metallic implant. Here we are talking about patient-specific scaffold. Again, research at VNIT, that means what we have done at VNIT, and finally the conclusion. So these are the main broad points that I will be discussing. As I already mentioned to you, that this is all about the research level. So let me quickly show you in introduction about the research. Now, I don't know how many of you people are aware about this quadrant, but this is a wonderful rather representation about the research, where they say that you have to always work on a quadrant called as the posture quadrant. It is because in posture quadrant, it is a use-inspired basic research is discussed. The pasture, he always used to work in a field which has the impact on the society, which is beneficial to the people in the world. And therefore, they say that your research should be on the pasture quadrant. That means it should have both the things high. That means there has to be more fundamental understanding, at the same time, more usage. Otherwise, they talk about the other two quadrant like Bohr quadrant and Edison quadrant, where they say that in Edison quadrant, they say that only it was related to the high usage, but there was nothing about understanding. That's what you people must be aware of. Like the Edison, he used to do only the experimentation, and Bohr, he only talk about the basic research. But how far it is useful, it is not very much revealed that time. And that's why they say that your research should be always on the partial part. Now, this is another quadrant called common man quadrant. Don't read that quadrant at all. Because, as I mentioned here, that it is low on a usage and low on a fundamental understanding. Please don't make any work in this particular quadrant. And that is what it is very nicely mentioned here. The knowledge created for immediate application. That is what we have to look at. And the another interesting point is business meets the science. Business meets the knowledge. And that is why the business and the science. So that's what exactly. And that's why, we take this particular arrow back to the pasture quadrant, and you have to work in the pasture quadrant. So as they say that it's the Bohr quadrant, the science and knowledge gets created. In Edison, business and knowledge is applied. But actually, when the business meets the science, you'll find that it will have an immediate impact as far as the application is concerned. So let us look it from this angle. As I already told you that this particular work on the tissue engineering, which is presently at the research level, and maybe we are trying our best to deploy it also. We are executing it in this CAD/CAM center. Again, as I already told you in the last class, the last lecture, it's my standing invitation to all of you to please do visit our VNIT once all this pandemic and every problem is over. Do visit. We'll see that what exactly we do have in CAD/CAM center and how best we are doing this particular work related to the application on medical domain. Now, I would like to just discuss with our success. What success we got it, and that's what I have already shown you in the last presentation. Related to this particular project that we have completed, and quickly all the things that we have discussed in the last presentation, that how we have developed the metallic implant, how we have fitted into the patient body, and there are many live medical cases that we have handled. Even one of the case related to the spinal surgery, which is related to the scoliosis with Nottingham University, UK. So all these things are related to the metallic implant that we fit it into the patient body. So ultimately, this is all related to the metallic implant, and I told you that there is a need of developing the patient-specific implant using 3D printing. And for that, I already told you that the premium institutes and the research-based company, they should work together, and that is how the amalgamation has to be there. So that aspect we already discussed. So then what next after this? The next is tissue. So what is this particular tissue? This is really very interesting and very key area, which is a buzzword everywhere, especially in healthcare. And then what exactly we are doing? As I already mentioned to you in the last class, that we are actually discussing about the metallic implants. Now, these metallic implants, that means you are just putting the metal into the patient body. It is like a foreign body in foreign body in the our body. That is very bad. If something gets stuck after we eat, and if something gets stuck between our gum and the teeth, our brain always instructs us, so please remove that. There is some foreign body in the gum and your teeth, so remove it. It is not required. So, even if you don't feel so, after some times your tongue will again go there, it will try to remove it and all that, because your brain is not happy with that particular foreign body. Now here you are putting the metal inside the body, so the whole brain that gets disturbed. Like, why is such problem? What is this particular metal is all about and all that. And therefore, there will be a lot of problems that gets created, and we are going to rather discuss it quickly. That there is a problem called metallolysis, there is a problem called shear shielding and all that. So ultimately, metal is not required, but we say that the bone, if at all we are talking about a bone, then bone is to be replaced by bone. That is what we talk about in medical literature. So replacing bone by the metal is not desirable, though it is a golden standard today. But you have to think about the ultimate goal of the bone to be replaced by bone. And for that, this tissue engineering plays the dominant role, wherein the some of the very important part of the tissue engineering called scaffold, cell, then clinical applications, and finally the development biology. All these parameters that we need to look into this particular tissue. So, what is this tissue engineering? Let us discuss about this tissue engineering. So, if you want to rather just write it down in a text form, then it will be mentioned the way I have written it in on the slide. It is an interdisciplinary, remember, because interdisciplinary talks about the all of them working together to achieve the aim of what? Of restoring the damaged tissue by combining the cell derived from a patient biopsy with a scaffold. And it is a principle of engineering and life sciences together. Here, what exactly it means, they talk about the scaffold. So, what is this scaffold? That again, we'll have to rather discuss it in much more detail. So, look at this particular figure, and you will find that it is really interesting to understand. So, for example, a patient lost a leg. So, what is done? Designed by scaffolding. A scaffold is designed where the cells are seated, and finally, both of them are merged to make the patient leg. Now, scaffold is the word which is very much used in our English language. It means a structure, open structure. And generally in civil engineering, they talk about the scaffolding. That means developing the scaffold means hollow structure, and then ultimately they put the material in that scaffold to make a building. Exactly in the same way, the scaffold is developed, and then you rather seed the cell in it to see that the tissue gets generated, which is nothing but the engineered leg or leg that becomes the available for us. So this is what is very simple representation of the tissue engineering. The tissue engineering bioreactor talks about the amalgamation of this cell and scaffold together so that it becomes the complete bone, it becomes a complete organ. So this is a very simple figure, and it talks about the scaffold. But if you look at the scaffold, these are some of the scaffolds that you can look at. This one is more important. If you can look at my arrows, you'll find that these scaffolds are nothing but a meshy structure, and this is actually related to the shape of the femur ball. And you can see the complete bone structure in a form of a meshy structure, which is a porous structure, and this porous structure is important. So, porous structure made of biocompatible material suiting to the shape of the organ to be implanted in the body is nothing but a scaffold. So, this scaffold fabrication is very important. And now look here, when I say this scaffold fabrication, the shape is really very complicated, very non-linear. In engineering, we generally don't like the non-linear shape. It is because there is always problem with the manufacturing or the fabrication of non-linear objects. And therefore, we always talk about the linearity in case of the engineering. But here you will find that there is more and more non-linearity, and therefore, in such non-linearity is there, the scaffold fabrication is possible by the applications of the rapid prototyping. And that's what I mentioned in this particular slide. The scaffold fabrication is one of the earliest application of the rapid prototyping, and now it becomes the more successful and mature. So we are now entering into the scaffold fabrication using this 3D printing, using the rapid prototyping, using the layer manufacturing. So how exactly this needs to be looked into? So that aspect I'm going to just discuss with you in detail. Now look at this particular slide. It is quite easy to understand and it's very much focused about the scaffold. Now the point related to is about the bone scaffold, and I'm talking about the bone tissue engineering. Does it mean that the tissue engineering refers to any other organ? Yes, it is possible. You may say that the tissue engineering related to the liver, tissue engineering related to the heart, engineering related to any organ in the body. It's possible. And we are focusing more attention on the bone. It is because the bone tissue engineering is comparatively easy than the other organs, because other organs are more complicated. And as you know, we are in the research stage. Naturally, bone tissue engineering is the first one which has been handled all over the world. And now slowly they are entering into the other domains like liver and other organs. But it will take its own time to get the success in the deployment of the research related to that organ. But bone tissue engineering is possible because you can actually see the bone getting developed in the area where there is a bone defect. So look at this particular bone defect. It's a major defect. So whenever you have a major defect like this, you can use the scaffold-based tissue. So what type of the scaffold talks about? So here I have just shown the two types of the scaffold. One is the ceramic scaffold, another one is the polymer matrix or polymer scaffold. Now here, the ceramic scaffold is more in use or more addressed because the ceramic is very well proved to be biocompatible. So there are a lot of work going on uh, as far as the polymers is concerned. But ceramic scaffold are very much used, and especially in case of bone tissue engineering, ceramic scaffold is definitely preferred. But there are other problems also with the ceramic scaffold that is related to whether that particular area is a load-bearing area or a non-load-bearing area. All these things again comes to picture later on. But presently, at this moment, we are only working on a non-load-bearing. So this is what the scaffold that you should be aware of. And as I already mentioned to you, that why do you want to go for the scaffold? It is because, as it is mentioned here, the metallic implant is causing metallosis. Metal are heavy, integration is slow. I don't know how many of you people are aware of. There are three basic metals which are very much preferred as far as the metal implant is concerned. And that they are stainless steel 316L, cobalt chrome alloy, and the third one is the titanium alloy. Now, out of that, the titanium is better because it actually helps in osteointegration. But in case of titanium, it is very costly and difficult as far as the fabrication is concerned. And therefore, the stainless steel 316L, which is cost effective and biocompatible also, is preferred. But it is heavy, integration is slow. That means it is not giving us a good osteointegrity. And on top of it, there will be a metallosis also. So ultimately, the current methodology of reconstruction with metallic implant is to be avoided. And that will be only possible if we think of the scaffold, then sear the cell and the bioactive molecules. We call it as a growth factor. And you'll find that slowly the bony implant will start growing. That means bone regeneration will start. The cell tissue, yeah, I think you should, I don't know how many of you people are aware that whenever the cells, the stem cells or the active cells from the patient, if they are put into the organ, slowly they will form the tissue depicting that particular organ, and that means the bone tissue. Okay, so the what we are now looking at, the lightweight bioactive material reconstruction to repair and heal bone defects. So this is one of the very interesting slide related to the bone tissue engineering. I would like to show you something more related to this. This is what we have tried as far as the RP assisted scaffold fabrication is concerned. Now look at this very carefully. Now, why you want to go for the rapid prototyping assisted scaffold fabrication? This is because, as I already mentioned you in the last one, that you can use the ceramic scaffold. So if you can use the ceramic scaffold, try to get the ceramic scaffold using the rapid prototyping machine. Very simple. What you have to do is that I want to rather fit some scaffold in the patient body. So I'll just take the MRI or the scan, then ultimately get the complete scaffold fabricated. So then that one scaffold fabrication using the porosity, everything well decided, suiting to the patient's anatomy, suiting to the patient requirement, so that there has to be some regeneration of the cells. So ultimately that you can use it in the for the rapid prototyping, and ultimately this scaffold that you develop, you can then ultimately put it into the patient body, where it will be possible for you to develop the tissue construct. Now, this is what exactly is one of the case that we have carried out, that we have prepared a slurry, we have made a bioceramic scaffold, then we have sintered it into the furnace, and finally feed it into the patient body. But what you'll find that this particular methodology is quite complex. At the same time, the various features that are required in this case is that how perfect your porous structure is and how it will be possible for you to get it fabricated. This is really very tough. Now, you know, the rapid prototyping machine is only programmed based on the horizontal and the horizontal so-called the construct in X and Y direction. Maybe layer by layer. But ultimately what you'll find that we need to think of the porosity by using the construct which will have a different architecture. Because as you know, as it will be easier for, as we go for the various design features, it will be possible for us to develop the construct, porous structure, which suits for the cell to rather develop in the tissue for fast osteointegration. For that, the next very interesting instrument is a 3D bioplotter. We are happy to inform you that the 3D bioplotter is available with us in VNIT. There are only 2 installments in India as far as the 3D bioplotter is concerned. One is in IIT Kharagpur, another one is in VNIT Nagpur. And we are, I'm really happy that we have used this 3D bioplotter for the tissue engineering, especially for preparing this scaffold construct. So what exactly we have done in this, but using this 3D bioplotter, that I'm going to explain you to the what is called as a patient-specific scaffold. Now, you know, when you talk about the patient-specific scaffold, that means it is related not to a standard scaffold or not for the standard so-called the cases of implant. As you know, I already told you right at the beginning that the standard metallic implant, that's the gold standard. Anywhere you'll find that is what has been practiced. But when you talk about the scaffold, that to patient specific, then there has to be certain applications. Where exactly such application is, that is what I would like to first explain you through some of the case studies that we have carried out. A simple case report, though I can read it quickly. It's about the female who has suffered from the problem related to the mandible. They call it the carcinoma. That is a cancer. And that needs to be removed. And it is to be reconstructed with the suitable customized scaffold of HFDC. Remember, HFDC is nothing but a ceramic scaffold. So remember here what we have written along with this case study. To improve the accuracy of the mandibular reconstruction surgery, advanced tools like Mimics 14.11 for image processing, 3Matic 8.0 for virtual surgical planning. The design is customized scaffold and it is with the surgical guides. That is what we have used, customized surgical osteotomic guide and the rapid prototyping for manufacturing of this tumor resection and exact fixation of the scaffold in the mandible that was found. So let me explain you through the figure so that it will be more more clear to you. So look at this particular figure. This first figure talks about the 3D CAD model of the mandible. Okay. Now, the affected region of the mandible is now indicated here. So this is the mandible affected. This is where you will find that there is a carcinoma. Now, what exactly they do? They need to rather remove that much portion and fit the scaffold in it. Is it possible to do? Yes, it is possible to do. Just look at this. I hope this figure makes it more clear to you. This is the customized scaffold. Okay. Now, what we have done to the mandible, this is the actually surgical guides that has been fabricated. Why this surgical guide? It is because it is easier for the surgeon to cut the part using this surgical guide. He can put a scalpel in this particular gap and cut it so that the whole portion can be very easily removed. Not only for the ease in cutting, but also the scaffold that you are developing. That is what we have already mentioned in one of the slides here. That this has been developed by using the thematic and the mimics tool. So this needs to be proper. This is already been developed. We do want that it needs to be properly fixed. Okay. And once you fix it here, there should not be any problem with the scaffold that is fabricated. So the design of customized scaffold using surgical guide plays the dominant role. So what you can do here, you have developed the surgical guide. You can use the 3D bioplotter to actually see the working of the bioplotter here. That this 3D bioplotter, and this is how the customized scaffold has been developed. Okay, and you'll find that these are the various ways by which the scaffold can be fabricated. The architecture, you can see the different lay pattern. Now this is interesting because you can actually think of the which one gives the best so-called cell regeneration, faster regeneration, faster osteointegration. This is what exactly we are looking for. So you can definitely get the different laydown patterns, use the bioplotter to get that particular scaffold. So once your scaffold is ready, once your CSOG, that means your guide, the surgical guide is ready, I think you can definitely work on the complete surgical. So this, whatever I talked about, is about the surgical planning. See, whatever I discussed about is surgical planning. Now, surgical planning is more important in any subject. So if you ask the doctor, any surgeon, he will always say that the surgical planning is more important. Basic surgery is okay. If your surgical planning is perfect, surgery is not a big issue for him. He can work for 7-8 hours on the system, on the patient, go to get the surgery done. But surgery planning has to be perfect. And this is what exactly the actual mandible reconstruction and the fixation of the scaffold in the tumor resected part is being shown here. So you can see that how the part is. I think you can see that again. Sorry for that. Again, sorry for the blurred pictures. But this is how the part is removed. And in this is what I have mentioned. This is the resected tumor, and ultimately here you'll find that this is the scaffold that gets customized, which is properly fitted. It is because you have already taken care by using the surgical guide. You know where exactly it is to be fitted, and you'll find that there will not be any gap, so that there will not be more stresses. All these things has been discussed. We have one of my PhD students has done the complete work on the surgical guide, and he is now having his company, and he is actually running that company with the Big Grant. So these are the mechanical results that we have obtained for the scaffold, as I already mentioned to you. And you'll find that this particular pattern of 0.45, 9135 gives a very good compressive strength. So, and these are all the detailing and about the various scaffold. So this is the SEM micrograph of the scaffold, how they are being properly laid down and all that. Ultimately, what you will find, it is not only the strength, but also the cell regeneration. Both things have to be properly need to be taken care of. It is not about only the pore size, but pore integration. The pore going from one location to the other, there has to be the porosity is also important. So all these things is very important for you to look at. So this is all about the customized scaffold. That is what I talked about. The next one is about what research we have done at VNIT in nerve tissue engineering. I told you about the customized scaffold and all that. This is also one of the very nice study that my student has done it. But let me show you again an interesting cycle so that you can understand about the bone tissue engineering that we are presently practicing at VNIT. So again, I don't want this cycle to be completed because I don't want a healthy individual should meet with an accident. So here, look at this particular cycle. You'll find that the CT scan, once you get it, then you use the 3D bioplotter here rather than your rapid prototyping machine. Because here, the 3D bioplotter will actually help us in getting the scaffold fabrication. And that too, the customized scaffold. The customized scaffold is then actually seeded with the stem cells, and then they are actually incubated in the CO2 incubator to see that the cell starts developing. Then you can use through the inverted microscope whether the desired differentiation of the stem cells has happened. You can test that particular scaffold for the quality and safety, and again use it use for the patient in a surgery to make that particular individual healthy. Here are this particular cycle talks about the stem cells that which you can take it from the bone marrow or the centrifuge or the ultraviolet temperature freezer. You put it in the stem cells to the stem cell bank and all that. But here, this particular cycle talks about the scaffold fabrication in which the cell are seeded externally, in vitro, and then you put the in vivo the scaffold with the cells together. So this is what exactly the methodology that we talked about. Now here, I would like to tell you that one of my students has actually completed his PhD on this particular area of bioprinted scaffold and how the one. So as I already told you, the various pattern he has actually developed of the scaffold. And what is important that whenever you are required to go through the any case study, first it is important that you should go for the animal trial, and that is what he has done it. The bioprinted scaffold with the deployment. So we have actually gone to the regulatory one who has helped us in animal trial. So here you can see that the complete scaffold has been tested in a GLP certified lab. Then we have actually seen the in vitro cytotoxicity of the scaffolds, and then these particular scaffolds, they have been actually tested for the in the rabbit, where you can see the two interesting rather the groups wherein you'll find that this is kept without the scaffold and this is kept with the scaffold. You'll find that the scaffold wherein the scaffold was in his tibia, when the rabbit tibia we have put it, and you'll find that with the scaffold, the regeneration is very fast. Ultimately, what is found is that if you look at this particular picture, that the X-ray shows that, and there is look at this, the right leg and the left leg, you'll find that the slowly the bone starts regenerating in the area where the scaffold was put and not in the area where the scaffold is not put. So we have actually tested it. Then we have actually taken the histological sections of the specimen. All these things generally is required to first get it approved whether scaffold is really helpful in developing the cells and the cells are not dying. So all these reports are available. This is what he has actually executed in his PhD work. And finally, what you'll find that the complete stage of development is very well can be represented the way we have shown it here in this particular slide. That the scaffold having all the text with the skin sensitization, bone implantation, and then we are entered into the clinical trials at the DIMS, that is Medical Sciences Verma. But generally we don't call it as the clinical trials, we call it as the case studies, because ultimately we'll have to first make it clear whether the whatever methodology we are using is okay or not. And before we enter into the clinical trials, we have done some case studies. So one of the very interesting case studies is the first cranial surgery that we have done it at PIMS one. Now you can see here, this is the cranial surgery where the portion is removed by drilling this particular skull. Now, once you remove it, then the tumor is, or whatever the operation or whatever the methodology is carried out for the brain, that has been done. But ultimately, that particular part of the cranial is now simply suture like this. You can see here the suture. The holes for the burn, you can see the holes here. Can you see the holes? These holes are actually for the drilling. Now that remains as it is throughout the throughout the life of the patient. So we have actually done the first cranial case studies where we have put the scaffold in this particular area, which was otherwise left unattended. Which was so that's what we have mentioned here. The 3D plotted scaffold placed in burrows for complete regeneration of the defect. So we actually looked at this, that whether it will be possible to generate the bone in that particular area. Remember, as I already told you, we were more interested in the non-load bearing area. And therefore, the non-load bearing area, you'll find, because this is all the non-load bearing area. So we have actually put this particular scaffold in that particular bird and observed how the scaffold gets developed. Yeah, there was a lot of problems associated with the patient, especially the patient age was one of the major criteria. As the patient was having the age more than 50 years, it was difficult for the bone to regenerate, especially in the cranial side. And therefore, we were not happy with the whatever the results we got it. But we realized that if he would have been younger, the thing would have done would have got it very fast, because the bone starts regenerating very fast in the younger people. So this we got the results. Some bone starts regenerating and all that, but ultimately this is one of the first cranial stage surgery that we have done. I already told you about that particular case study, which we have already explained during the customized scaffold, that this is how the customized scaffold has been put. So that is again the first case studies where we have actually featured the scaffold in the patient who are suffering from the cancer. So this is one of the wonderful work wherein the surgical guide was also designed, the patient-specific 3D plotted graft was also designed, and a complete regeneration of the scaffold was possible. And this is, as I already told you, my student has got PhD based on that. This is about the mandible surgery, as I already mentioned to you here. So post-operative surgery, we found that the clinical and thermal image also very nice. It was a wonderful results that we got it here. Another interesting point is about the socket preservation for the post-implant test. So this is what we have done it with the Dr. Vidya Baliga at the DIMS Varda. Now, generally, when the implant is fitted, the socket needs to be properly preserved. So there, you know, we have actually developed the scaffold, which was properly fitted into the socket, and so that the implant can be properly fitted into the way. So this is the first dental case. Then we have carried out number of dental cases, like the second dental case again here, wherein again the socket preservation was a problem, and therefore reached with augmentation. Then the third one is again on the socket preservation, and the fourth one again on the socket preservation. So a lot of work we have done it, and we found the result very promising. Especially, we have seen that the dental side, the results are very promising, and the bone regeneration also takes place very fast. So with this particular approach, we found that the uh, uh, the scaffold development in the dental side can be used extensively. And why I have discussed all these things with you here is because this talks about the research deployment. Though I told you these are all the case studies, we are yet to start with the clinical trials, because unless the thing is approved, there is no point in getting the things deployed. But the clinical trials will be only possible once you have the case studies, once you develop the confidence. Now look at this particular word, confidence, and I'm going to rather talk about it. The confidence of the doctor. Now look at the way we have handled these cases, that we have rather taken the doctors right from the first stage. As you know very well, I have already mentioned to you in the last lecture about our first stage in Batik is to define. Now in the define stage, we ask the doctors to talk about their problem, and that doctor help us till the deployment of that particular work or that research or that particular problem. Now, you know, think of the situation, and the doctor X is ready to help you in the solving the problem, so that the whatever the new methodology you are talking about, which you may call it as a research, it is possible to deploy. Now the doctor is with you throughout the deployment. Now then, getting the result from the doctor saying yes, whatever we have done is perfect, whatever he has done is perfect, whatever the methodology he has carried out right from the first stage to the last stage is correct. But there may be some doctors, why? They may raise objections. They may try to comment on this, that whether this is perfect or not, and then the whole thing starts. The confidence of the doctor right at the beginning is more important. I'm really thankful to the doctors from the DMS that they have the full confidence on whatever we have done at VNIT, and therefore they are ready to deploy that in the patient body. But whenever we have to see that the confidence of the doctor, not only at the area where we have started, but all over the world, all over the medical fraternity, needs to be properly developed. So, what is the methodology, or what type of what may be the problem? One of the problem that I have seen, especially in scaffold fabrication, the way I told you, is related to the scaffold fabrication using the bioplotter. The human intervention in the whole process of scaffold fabrication is much more. If we can reduce the human intervention, that means the human intelligence, if it can be taken care by something else, so that the confidence of the doctor increases. That is the need of an hour, and that is what we are looking at the next part at VNIT tissue engineering. So look at this, what I have written. The area of artificial intelligence in tissue engineering is more important. The human intelligence is to be taken care by the machine intelligence, so that there will be less and less human intervention. If there is less and less human intervention, then you will find that ultimately the uh, chances of making mistake is less. If the chances of making mistake is less, naturally the confidence of the doctor in getting that particular scaffold accepted for the surgery is more. I hope you understood what I say. So look at the scaffold fabrication that we have done it in our VNIT lab, and asking doctors to give the consent of that particular scaffold for to be used anywhere in the world. They may have the problem saying that, okay, this is okay, but there is more human intervention. We'd like to see to what extent this is possible, because ultimately getting the approval from the various committee itself is a big issue. But if I say that this particular scaffold is developed using the artificial intelligence, where there is a minimum human intervention, hopefully the confidence of the doctor will increase. They may would like to see only your complete system of AI, what you have developed, and that is what we are actually interested in, and that is what we have already submitted the proposal for this particular area of AI tissue engineering. We are waiting for the proposal acceptance by the end of this year. But if it gets accepted, I hope maybe next time I can explain to you how exactly the AI can be used in tissue engineering. Another very interesting point, and which I have mentioned, the proposal to be prepared for in vitro organ development. Yes, whatever you are seeing here is perfect, is correct. That heart is fabricated using a 3D printing. That means you are directly fabricating the part, organ. Yes, that's the need of an hour. Look at this particular graph. This is the graph related to the need of an organ in US. Okay, such a perfect data is not available in India. You will find that the waiting list is continuously increasing, and the donors are almost on a simple straight line. So naturally, the gap, there is a wide gap between the supply and the demand. Now this needs to be filled. Now how do you do that? For that, okay, whatever the methodology presently being practiced of getting the donor, the organ from the donor, and I think the green corridor and everything you people must be aware of, that may be the one of the methodology by which we are meeting this particular demand. But if we can talk about the organ development in vitro and then fitting that particular into the patient body so that the affected organ get replaced, I think that is possible using tissue. So as I mentioned to you, we are only focusing on the bone tissue engineering. But if you look at in future, you may find out the organ like the liver or the heart or the kidney is being developed using the tissue engineering. That is what we talk about the soft organ tissue engineering. This is what is the new area where the lot of research work is being done, especially related to what type of the scaffold fabrication using the biocompatible material. Now the ceramic is big no there, and then they use the different types of the polymers and all that. A lot of work is being done. And as I mentioned to you, we are also interested in submitting the proposal for such in vitro organ development. Ultimately, it is because you know the important point here to look at. If we look at these two areas where we will be more focused on, that with these proposals, we will be definitely meeting the need of the people in the society. You know, as I told you right at the beginning, the quadrants. So partial quadrant talk about the user-inspired research. So if I simply get the research done without the use in the patient, it is not a research which is user-inspired. So to remain in the partial quadrant, I hope this is the right methodology that we'll have to follow. And with this, it will be possible to rather meet the demand of the people in the society. And not only that, you'll find that the health sector will definitely improve. The doctors, they get a lot of confidence with all these approaches, the way we have done. And I'm very much for the course, where the doctors and engineers are learning together. One of the nice courses is being run at IIT Bombay, where the MTech in biomedical engineering is offered, where the doctors and engineers are working together. I think such courses should be run in all the institutes in India, and see that the doctors and engineers are working together, especially in this high-end research, where you'll find that the application of the research or the deployment of the research is beneficial to the people in the society. I hope for the tissue engineering, this should be sufficient enough to digest, because there are so many things yet to get discovered. A lot of work is required to be done. I hope let us look at the conclusion, that what exactly the tissue engineering with the bioplotter is important. So before that, let me share with you success in the deployment of the PhD research. So we have won the Innovation Growth Program University Challenge Award, where you will find that this is an extension of the PhD thesis of Dr. Pranav Sapkar. So he is Pranav Sapkar, and this is the one of my student, Prashant, and with me, we have won the 10 lakhs award from the IIGP 2.0, which is actually funded by the DST Lockheed Martin and a Tata Trust. And there we have been asked to develop the scaffold, patient-specific scaffold, and they are actually doing it. And based on their work, they will be rather starting the new company. So that is one of the interesting, rather the success in the deployment of one of the PhD research work. And that's what I'm really happy to share with you. Another interesting point is about we received the 2 BIRAC grants from the government of India, 50 lakhs each. And these are the actually grants based on the PhD work done by my students. One of the project related to non-invasive glaucoma detector, it was presented by the Betty Research in Nayalande, but this is actually the extension of PhD thesis of Dr. Mahesh Mavle. And the another one, which I already told you during my presentation, is related to the adjustable surgical cutting guide for accurate mandible tumor resection, which was presented for the grant. He got the grant, Dr. Sandeep Dake. He's actually the extension of PhD thesis. So what I would like to tell you is that the deployment of PhD research, I think that should be the culture. Whenever anybody completes his PhD, whether there is a startup in that PhD or not, that should be the first thing everyone should understand. That once the PhD is over, I think everyone should start their own company. And that is what is the solution for the unemployment problem in India. If we can start the company based on the PhD research, naturally the more and more people will get employed in that particular small companies. And you'll find that presently the existing or the core industries are finding more problem in offering the more and more jobs. But if you have the more such startups, then naturally the startups will be the job creator, and ultimately you'll find that the unemployment problem will be eased. So I'm happy to share with you our success. Finally, I should say that tissue engineering is the future of biomedical engineering discipline. That is what is important. The demand for the patient-specific organ will be met through the tissue engineering. That is also one of the wonderful, area where we need to work hard. All of us has to work together. You have to connect with each other and see that, as I already told you, research is not to be carried out only for paper publication or just to get the promotion, but the research should be carried out for deployment, for the benefit of the society, of the people in the society. And you'll find that the people will start looking at us with the pride, saying that he is a researcher who is more important. So I think that's the takeaway message from my side. I should say thank you very much for hearing my presentation. I think sufficient time is with us for the interaction. Hope it should be possible for us to. I'm just yeah, I think I should stop the sharing my slides there. Okay. So I think Pramod, I think I'm okay with my presentation. I'll be more happy to interact with the people in general so that it will be quite interesting. As I already told you, otherwise it will become a passive way of knowledge impartation, which may not lead to any success in long run. But if there are more queries from the participant, any comments on that, anything they found it quite interesting or maybe something catchy, I'll be really happy to discuss. Okay. Yeah.
Okay. Yeah, sir. So I request the participants, please, you can share your thoughts or you can ask the questions.
Hello, sir. Good afternoon to you. I just want to know, you are working with a single material or multiple printable materials?
As far as the bioplotter is concerned, you know, the HATCP is the material that we are presently working on. It's a two material.
Okay.
And we are actually using their combination just to find out that in which combination we get the more cell or rather the tissue regeneration or the cell development. So ultimately that's the work which my student has done. He has taken the different combination. So he has to put get the slurry prepared and all that. So at this moment we are only working on a ceramic. And as I already told you, we are working on a non-load bearing.
Okay.
Yeah. Yes.
Any other participants who can ask the question?
I'll be really happy.
Hello.
Pramod,
Hello.
yeah.
Good evening,
Yes,
sir.
Yes.
Sir, first of all, I congratulate you. Your research work is very useful for common people, and actually, you are working in a very great way. Sir, I want to ask you from where I can start my research in 3D printing. Actually, I am very much interested in this, but just I start studying about these things. So from where I can start, because when I attend these type of any workshop or anything, so research actually is in very advanced stage. So I was unable to understand from where I will start.
Yeah. Very nice question. I think let me address this to all the participants because it happens like we always look at the research with a pinch of salt, frankly speaking, in our engineering because everything is already applied, everything is known. There is more complexity sometimes we should look at, and then we get confused that from where I should start my work. The best thing would be start taking baby steps. The baby steps in the sense, look at whether you understand the, say for example, 3D printing. I have shown you one slide, maybe in my last lecture. There are engineering application and there is medical application. So in engineering application, one of the area is about the conceptualization of the product, design of the product. Now, if you look at that part, you'll find that there's a tremendous opportunity as far as the research in 3D printing in conceptualization of the part is concerned. So what exactly the conceptualization is, you can look into that detail. You will find that there are various theories available on conceptualization. One of the thing I already told you about the bionics. The another one is the trees. There is the Archular theory. So if you can only focus your attention more and more on the conceptualization, you may find that the 3D printing is very catchy because whatever the concept comes in my mind, immediately I want that thing should be available in my hand and it should be possible for me to show it to the people in general. Oh, this is what the concept. For example, the flying car. The car, you always require the car which will overcome the traffic jam. Though now with the corona, nothing, there is no traffic jam anywhere. But with the traffic jam, you always feel that if I can have the flying car, which can only overcome this much of traffic jam, and then again it will be on the road and I can then reach my destination. Think of the concept. The concept is like, if you again talk about the aircraft, things of that nature, that is an existing product. But can you have a different product? Say, for example, based on the concept that you can take it from the, say, leaping of the kangaroo, and hopefully you can develop the car like this. So I hope this is where you can start your work. Think of the conceptualization stage, develop the concept, get the 3D printing of it, and then you will slowly find that you will enter into the research, like how exactly the product is to be developed. Now, if you look at the medical domain, I already told you there are a lot of things to be done. Talk to the people, those who are in the medical domain, especially the doctors. Ask them about their problems, that what problem they are facing. That is what I always used to say in many of my lectures, that have you seen any doctor or surgeon coming out of the operation theater and simply saying that yaar sab bigaad diya maine, kuch samajh mein nahi aata, gone, wo gaya. This is not possible. He will always come out of the operation theater and he will say that, okay, I have taken my care and operation is successful, and you are with me, God is with us, and everybody is there, then everything will be fine. But think of the problem that doctor faces in the operation theater. Once he cut open the body, he cannot simply say, oh, there is so many complications, yaar, kaise karenge? Kal aa jao yaar, nahi hota aaj. This is not possible. Then, once he cut open the body, he has to finish the operation and he has to say that everything is fine. He cannot call the patient again for the operation. So, ask him, what are his difficulties? What are the problems associated? And that's what I told you, like the metallic implant, the scaffold development, all these are the catchy area where you can always start working on, and you will find that there is a tremendous opportunity. Try to interact with the people, those who are already working with them. Try to send the emails to them. Tell them that this is what you have done. You have your BTech projects or MTech projects, say, for example, if you at all you are the faculty member, you are guiding them, then you can always take that particular projects in that direction. Inform about the projects to the people, the people from the faculty members from the premium institutes. You'll find that you yourself will understand how exactly the research is to be executed. But I think, yes, you are on the right path. If at all you feel that you are confused, you are on the right path. You can definitely take, you will come out of this confusion. So, yeah. I hope I answered Madam's question. I don't know to what extent she is.
Yes, sir. Thanks a lot, sir.
Yeah.
Yeah, any other participant who can ask the questions?
I'm really happy that in this session there are more questions, because if there are no questions, then I always feel that passive learning or teaching is big no. We have to interact. We have to interact a lot. With more interaction, I hope we learn a lot. I don't know how many of you are aware of the Stephen Hawking, a physicist, a researcher. He says that at every day 4 o'clock he is to attend the tea club in University of Cambridge. It is because there he learns a lot rather than learning through the books or anything else. So that's what he always used to say, that interaction in the tea club is actually help him to develop his scientific temper. So like that, if anybody is interested, I'll be really happy. And I'm happy that around 7 participants are there. So you know my email. So anytime you can send me the query through the email, be in touch with me. Tell me what you people are doing. As I already told you, that I'm happy that if you can come to Nagpur and see our CAD/CAM center and see what we are doing, Yeah, maybe once this all problems are over of COVID-19, but it will be my pleasure to show you, and maybe I can take you to our medical institute at Varda, where we have actually done the work related to this. Lot of work is required to be done. You know, the research is a group activity. I hope many of you people must be aware of. The Dr. Abdul Kalam, he always used to say that it is a group activity. And he always used to say that I cannot do anything alone. I like to work with the people together. And once the people start working together, not keeping the ego, if they have to simply throw the ego in the basket, waste basket, and start working, hopefully the research is successful. And that is what is required in India, in our developing countries like India, to see that we compete in the world.
Any questions? Any other participant who want to ask any question? You can ask anything related to research, not only on this topic, as sir is very, I mean, on the mood to talk on any of the questions. It's not related to the sessions. It might be regarding your research work, or where if you're stuck somewhere in between, or you want some path to know how to tackle that problem. So please, be feel free
Yeah,
and ask the questions.
I'll be really happy. I'll be really happy. If you, as rightly said by Pramod, I think Pramod, you'll not mind I'm calling you by the first name, because I
Yeah,
always
yeah,
like to
it's
call
okay, sir.
everybody with
It's
the first
okay,
name.
sir.
Anyway,
I'm very younger.
so Pramod, thanks to Pramod that he has opened up the forum for discussion related to any topic. I'm really happy. It will be my pleasure. And as I already told you, that through the email, you are always welcome to, I think you may be knowing my mobile number also, so you can use the WhatsApp also to interact with. Pramod can send you the details of my email.
Yeah,
And
yeah, I've already shared in the PPT in the introduction session. So anyhow, I'll share as well. So any questions from the participants?
Yeah, good afternoon, sir. Dr. Ruchi this side.
yeah, please, ma'am. Yeah.
So as such, I don't have any query to ask. In your presentation, you said if there is any single point of that you find interesting. So I just want to say that your entire presentation was so interesting, informative, that there is not a single point that we can highlight. So I just like to say many congratulations to you and your team for doing such a fabulous work for the society. And somewhere you have given a new hope that soon we'll be able to make India Atmanirbhar Bharat. So thank you so much for giving us so many interesting perspective, and for showing so many interesting studies, sharing so many interesting studies with us. So thank you so much, sir.
Really nice, madam. Please be in touch with us whenever you
Sure,
want anything to work.
Sure, sir. We would love to see some more studies, because it's very inspiring to see that you and your team are doing such a wonderful work. So yes, keep it up, sir. We are really proud of you.
Thank you. Thank you.
Yeah, any other participant who can share his or her thought, or you can ask the question.
Pramod, you will be also getting the feedback also from the participants. So
Yeah,
please
yeah,
share the feedback so
I'll
that
be
it will
sharing
be
it.
easier.
Yeah, yeah,
Yeah.
sure, sir. Yeah.
So that
Okay,
it
is
will be
there
nice
any
for me.
questions? So shall I end now? So okay. So I hope it's we are ending it now. So thank you very much, sir. Thank you for the the thing is, what we were like, we are at now not of that senior, but we were used to like doctors and engineers are very different profession, and we were like rivals, as if we can say. But today, as what you have integrated the both of the expertise, that doctors and engineers can do the marvelous job what you have carried here. So it's really been it's been like, yeah, engineering can be in the doctor profession as well. And together, I just saw that one image where you had a doctor and then side by you had a mechanic. So it inspired actually. It is like many things as inspired today, that your deployment word, your lot many things on the word lines by the most more of the uh, uh, worthy men, like you said about Abdul Kalam sir and others.
Yes.
So really, sir, it was not just only related to the technical session, but we all also had the great exposure to how to start in the positive way. And as one ma'am asked about the how to start with the research, it's like a very confusion stage at the first time. Even it was at my time. So it is everyone's questions, and she asked, and you had given a very well answer for it. So I thank you, sir, from my bottom of my heart, from the Bharati Vidyapit College of Engineering, and also from the ATAL AICT forum. So thank you so much, sir, and always be in touch with us. So thank you
Yes.
again. Yeah.
Yes. Thank you. Please be in touch. Okay.
Yeah.
Thank you.
Yeah.
Thank you, sir.